Hello students and welcome back to Lazy Chemistry. Today what we are going to be doing is we are going to be doing the infamous BEan Lab and explaining what normally happens with the BEan Lab, creating data for the BEan Lab and explaining how this is a good allegory for us going forward for our average atomic mass. This lab here is a traditional lab that is done, to be honest, in every single chemistry classroom all over the world. And the reason for it is because it's a really easy lab because it has beans, and nearly every culture uses some form of bean, in their staple diet as is. And then the other one is that it's probably the best method for us to go ahead and learn some of the processes for average atomic mass. Now, how this lab is presented is that they typically say, okay, we have a new element, and we usually call it BEanium. And if your teacher doesn't call it BEanium, they're some kind of scrub that doesn't understand that you need to have fun. And BEanium has 3 different isotopes. One isotope is going to be, here in this case, the chickpeas, and this isotope has a specific weight to it. The second isotope has a different weight to it. And then this last one is the black beans, and they have a third weight to it. Okay? And our goal for this lab is that we're going to go ahead and count up how many of each type of bean that there is. And then we're going to go ahead and figure out the average atomic mass of the beans based off of the information that's given. Okay? And the whole point of this is to show, hey, our relative abundance in nature, or how abundant different beans are, is going to affect the average atomic mass. Okay? So one of the things that happens a lot in nature is that even if we have 3 different types of beans, those beans aren't going to show up in the same ratios. Okay? A common example of this is that if you go ahead and take a look at carbon. And carbon as an element has 3 different isotopes that are really common. It has carbon-12, which has 12 protons, which has 6 protons and 6 neutrons. You have carbon-13, which has 6 protons and 7 neutrons, and you have carbon-14, which has 6 carbons and 8 neutrons. Okay? And when you look at carbon on the periodic table, what you'll notice is that it has a weight of 12.011. Okay? What that means is that for carbon, a majority of it ends up being that carbon-12. Because the average atomic mass is so close to 12, you can go ahead and assume that the majority of the sample ends up being that carbon-12. And this lab is just a good way for us to go ahead and show it. Now, this lab, what I could do is I could sit here and count all the beans, but you understand that that would be an unlazy way of doing things. Instead, what I'm going to do is I'm going to go ahead and give you amount and the weights of the beans that you guys can go ahead and use. And those students that are in class are going to be the ones that get to actually count all the beans. And you might laugh and say, Mr. Bradley, are you really going to make them count beans? And I have done many more petty things. One of my favorites is counting rice, but that's a different story. All right? So for now, I'm going to go ahead and leave you guys off. And remember, if you can find a way to do it lazy, that's the chemist way.